Hello, I'm Rajesh Bhaskaran. I have a fun job teaching engineering simulations at Cornell University. In this video, I'm going to give you a quick demo of running a complex engineering simulation of fluid flow in a web browser using Amazon AppStream. And this is the kind of simulation that not too long ago you needed a dedicated supercomputer to run on, and now you can run it in a web browser. And after the demo, I will discuss how this enables exciting new ways of teaching and learning. I should emphasize that this is a pilot right now at Cornell University, and that's being tested in a few selected courses, and it's not yet a service provided to all students and faculty, though I'm hoping that the powers that be consider investing in this service. The example I'm going to show you involves simulating the fluid flow or the airflow over a model wind turbine rotor that looks something like this. And so students design this and 3D print it and test in the wind tunnel to figure out how much power they can generate. And another group of students does a simulation of the fluid flow, and they also predict what kind of power you can get out of the rotor, and the idea is to compare the two. Let me hop over to the AppStream, and it's running in a web browser. And so, over here I can see all the apps that have been provided to students. I'll use Answers, which is a powerful simulation tool used by professionals, and it's not available on Mac. But this way you can also run it on a Mac. And this is one of the Answers windows, and I've zoomed in on a model of the blade. We use some tricks to model only one blade rather than three. And if I can zoom out, and basically what I see is there's a region around the blade. I have to put a region around the blade, and then I have to divide that region into little chunks. This is called meshing, and I can cut through that mesh and examine what's happening near the blade, which is quite important for accuracy. And what's really nice is I can move this around, and when I do this, I'm really amazed that I cannot tell that this is all happening on a remote machine. For the most part, I cannot tell. So it's the interactivity is great, and then I can run it on, in this particular instance, on up to 4 cores to solve the equations, and then I can look at the results. For instance, this is the pressure distribution over the blade, and you see I have constructed the other 2 blades just as by reflecting this original blade. And the hub is not modeled here as an approximation that you can bring in at a second level of approximation. And one could also take a look at other things, like what happens so let me just go back to one blade and then look at what happens to the flow over the blade. So for instance, if I release a particle over here, according to this simulation, it's going to flow like that, and you see you have this what is called a dead water region that is low pressure, and that leads to losses. So ideally one would redesign this blade to minimize that. So that gives you a quick demo of a very cool simulation that is even made cooler by being able to run in a web browser. Let me move on to talk about why is this service important. This is new technology because each user gets own server on demand. So when a student launches the AppStream in a web browser, she or he gets a server from this huge fleet of servers provided by Amazon Web Services. And this means that you have the same solution for 10 students or 100,000 students, because if you had 100,000 students, each of those students would get get a server from this massive fleet of servers provided by Amazon. This is, in contrast to conventional services that I'm used to, where you have a big machine that's shared by users, and as more users get on, you get a slowdown. And this enables exciting new ways of teaching and learning, and I'll just indicate a few. For my own work, it helps with the democratization of simulation. My vision is a democratization of simulation, whereby every engineer is able to use powerful simulation technology effectively. One aspect of it is online learning, and I've demonstrated some online learning tricks that I use in this particular demo video. And the other is easy access to the simulation, because you're learning by doing. And through the AppStream, the students get very easy access to the simulation tool for hands-on exercises. The service enables students to use software for group problem solving. Group problem solving is a very effective way to learn compared to the conventional, the professor on the stage lecturing at students. So if you want to have group problem solving in class, if you want to have it outside of class, I see students in the lounges around our building, sitting in groups and working on stuff. And now they have access to software. And engineering, for instance, is a very tool-driven discipline. And if you have access to the software, then it makes for much more effective problem solving. Distance learning is a rapidly growing part of higher education. There's demand for it, and universities are interested in meeting that demand because it entails more revenue. And this way, through this service, you can provide software access to distance learning students. There's no difference between them and the on-campus students. The service enables software instruction in regular discussion sections. For instance, students in one of the courses where we are piloting the service, they were able to do hands-on, sessions in the discussion where they were going through a material selection tool. Previously, the teaching assistant just demonstrated the tool and students watched, whereas now the students were able to follow along, and so there was a hands-on component to it. And there are a bunch of other things, and this is not exhaustive, that one can think of where the service is important. And I've listed them, and I won't go through them. You can pause the video and read through them if you're interested. Hopefully that gives you a sense of how, through the Amazon AppStream service, you can run exciting apps, including simulation apps, in a web browser, and how this enables exciting new ways of teaching and learning.